Dive into the world of data center innovation with the iMasons podcast, discovering the people leading the industrial revolution. My name is Romain Trunchant, and today I'm joined by Tony Virr, Operations Director at Carbon Z. Moving on to new projects and programs at the end of January, Tony has accumulated hands-on experience by designing, building, operating a data center, which houses a portion of immersion cooling. He has agreed to talk to us about his experience, the good, the bad, and the painful of liquid cooling. Let's get right into it. Hi, Tony. Welcome to the podcast.
Yes, good afternoon, or is it good morning, good evening, good day? I realise that these podcasts seem to go global. So wherever you are, hello.
Well, first of all, thanks very much for taking the time out of your busy days to actually come and talk to us about liquid cooling. You and I have been talking for a little while around your experience, which I find really fascinating. As you've been taking a slightly different approach to a lot of people I've been talking to, which is literally to get your hands dirty, do the things, see what works, what doesn't, and so hence the recording today.
Yeah, that's true. I mean, my experience is all hands-on. It is self-taught where needed. It is through reaching out to peers, manufacturers of immersion kit, manufacturers of servers, materials, tables, the whole lot. I've had to go out and research the entire market. And that's what leads into the pain. It is a very, very slow process when you're self-teaching this sort of industry and industrial changes.
It's been a little while since we're trying to plan actually the discussion we're going to have today, and there is a recurring theme in our preparation, which was there is so much we don't know about liquid cooling, more in particular, and we're really going to dive down to immersion cooling today. And so what we want to go through today is really about barriers of adoption through liquid cooling, immersion cooling in particular. Can you give us a bit of a high-level overview of what you've discovered and what you've seen?
Yeah, certainly. So the barriers come in many different forms. The key one is the lack of knowledge and the lack of peers to be able to go to it. You go to one particular source of information, they will give you that information. But then you have knock-ons and so on and so on. The industry is so broad, to get specific or an overview is very, very difficult. Then you look into the lack of adoption in the market. There's not many people know immersion cooling is the way to go, or liquid cooling is the way to go. Server manufacturers currently don't shout, we've got our immersion capable servers available now. Health and safety, that is a huge barrier at the moment, and it's lack of knowledge. And the most important part is that processes are changing. Something, a simple task can take ages in immersion cooling, or it seems like ages in immersion cooling. Comparatively, minutes become an hour because of additional tasks that you've got to do. That's one group of barriers at this moment in time. I'm not even going to talk about warranties yet, though, for the end user. That's a completely different one. But that one does come out of the lack of maturity in the market at the moment.
And I think there will be other people talking about warranties in future episodes for sure. But let's start unpacking a couple of them here. So I wanted to come back onto the lack of knowledge. And one of the things that we've uncovered over time was everybody is really accustomed to doing things in air-cooled environments. They have set expectations as to what work, what doesn't. What's your experience about, for example, clients moving to the liquid cooling side, immersion cooling in particular here, and their change of expectations? Can you unpack that a little bit for us?
Oh yeah, that's a huge field. Is that clients' expectations are that why should it be any different to operate a server or to maintain a server in liquid than it is from air? Well, there's so many different examples I can give, but I can give prime step, which are processes, which need to be understood. If you take a simple task, like let's reseat the RAM in a server in air. It's quite a simple task. Everybody knows. You go to the rack, you open the doors, you power down the servers, you slide the server out horizontally. Some may remove the server from the rack, which is good practice. Others may do it in the rack, which is questionable practice. You take the server to a bench, you take the cover off, you undo a few screws, you then pop the little holding calipers on the RAM, you lift it out, you give it a clean, you drop it back in, you put the case back on. You can bench test a server in air to make sure that it's actually reseated correctly. Then you put it back in the rack, you slide it in, you switch it on. The whole process may take you 15 minutes. It's not a difficult process. Everybody knows that because it's ingrained. It's part of engineering training. They taught it at colleges, taught it at schools. They're familiar with it, and from building their own PCs at home. With immersion, that sort of thing does not exist. The same process to reseat RAM is somewhat elongated. For a start, you've got to get over the fact that your servers are not mounted horizontally, they're mounted vertically in some cases. And you have additional equipment to use. So you have to take a server, you have to power it down, that's fairly obvious. You have to disconnect all the power cables, all the network cables, and move them out of the way. You then have to use the crane to winch the server out of the oils. And then you go and have a tea break. And the reason you have that tea break is because your server has to drain. Oils have to drip out. And not only that, the server has to cool down. Servers are a lot warmer than they are in air because of the way that the oil works. It circulates warm oil, the chassis gets warmer, so it has to cool down. Once it's actually drained, you then have to carefully migrate your server towards a bench. And whilst you're doing that, you also have to prevent against additional drips of oil because you will never drain all the oil out whilst you're just leaving it hanging. You take it to the bench, you then put it into a cleaning bucket where you aspirate a degreaser against it. So you spray the degreaser onto the server. That is then going to soak your server again. The degreaser has to penetrate the oil, thins the oil down, and then it will flow out the bottom. So you've had another tea break. You then lift the server onto the bench, you lay it down on its back. You can then flip the little clip for your RAM, same as you would do in air. You lift it out, you take the RAM, which is now covered in degreaser and is also covered in residue oil, and you have to clean the RAM stick. But then you look at the spot that it's just come out of, and wait, it's suddenly filled up with oil and degreaser again. Oh no, you've got to get that out. So you're using compressed air to blow the oil out of the slot. You then think, great, okay, I've got that dried. Let's put the RAM back in. You put the RAM back in, you lock them all down, you put the covers back on, and then you think, I need to test it. But you can't bench test a server unless you've got an incredibly powerful wind tunnel, which can actually air cool a chip which is designed to be liquid cooled. So then you raise your server again. And as you raise your server again to take it back to the bath, guess what? More liquid drops out of the bottom. It literally gets everywhere. So you have to then create like a nappy for the server. You then carry the server, or you crane the server across to the bath. You suspend it above the bath. And then you then realize, I've got to lower it into the liquid, but hang on a second, there's all my cables for the other servers that are in the way. So it's like parting of the Red Sea. You push the cables to the side. When you get them to the side, you've got a little slot, 2U, 1U. Hey, you might get a 3 or 4U server, and you then lower your server gingerly into it. And as it's going in, you're checking all the time for other cables being caught, trapped, etc. And then finally, you get to the point where you disconnect the crane, you move it out of the way, you put your power cables in, your network cables in, and you switch on, and you're stood like this. And you literally are fingers crossed, because if it didn't work, that whole process to repeat. Now, that process doesn't seem, when I talk about it, that long. But on experimentation, by bringing in some external people from a server manufacturer to work with me and find out why it was taking so long to do such a simple task, their 15-minute task was taking in excess of an hour to an hour and a half per server.
Mm.
Now, when you've got a bath with, say, 17 or even 25 servers to you in it, an hour and a half task across those 25, you're nearly a day and a half of solid work versus 2, maybe 3 hours. That is one process change that changes the user's expectations. They have to realize that things are slower at the moment.
So part of there was really two sides to that story. The first one is the process have got to be written and followed. The other one is the expectations from whoever's asking you to complete the task and says, "Well, why don't you go faster?" But
Yeah.
human nature being human nature. We'll end up in a position where people risk taking cutting corners, and that might lead to all sorts of other different types of issues. And you and I have talked about health and safety concerns before. Can you give us a lowdown on health and safety and what you've seen?
Yeah, sure. Okay, health and safety in this particular environment is key. Let's take it your basic. You have to wear protective equipment, which includes rubber gloves. You may have arm gauntlets. You may have an apron. You need eye protection. You also need, because you're aspirating chemicals, you need breathing apparatus. At the very, very least, the old COVID masks, although they're not recommended, you should buy an industry standard face mask to cover the nose and the mouth. A lot of my experience, we actually purchased portable or personal rebreathers, which was a benefit to protect us. And so, ironically, the one piece of equipment in PPE which you may have in a data center, which is ear defenders, are not required. Well, hey, there's a win. We've made one step forward. Immersion cooling
Yep.
is silent, but it comes with all the rest of the paraphernalia. So that's that part. Now, you also have to bear in mind that servers that are going into immersion cooling are incredibly dense. As the density increases, the weight does as well. Servers that I've seen are 56 kilos each. So that brings into the fact that you also need a set of steel cap shoes. They're mandatory. They should be anyway in a data center, but they are mandatory in this situation. But also, you're dealing with hot oil. You're dealing with heavy weight. You've got an oil. Oil, by definition, is slippery, but this stuff is insanely slippery. And so you've got to bear that in mind. And a job that you could normally do on your own is not advisable. You need 2 people. So that scenario which I gave you before, just to move a server which is hanging on a crane, is a 2-person job. That's straight away. Now then, you also look at health and safety from the bigger picture, the ISO 45001. You have to do risk assessment. And risk assessments for the oil, it was new when we did it. We actually brought in a seasoned health and safety assessor to actually assist us in producing our risk assessment for the oils and the use of. It took him 2 days just to go through the basic ISO 45001 storage, use of, and containment of oil. And the reason being was they're slippery, you're heating them up. What happens if they get too hot? Will they burst into flames? Can you smell it in the air? As in, is it vaporizing? That sort of thing, as well as what to do if you get any in your eye, what to do if you get it in a cut, what if you ingested it? All these sort of things are your 45,001 things. The most interesting one, which, as I've said and hinted at, is the fact it is slippery. So what if it gets on the floor? And that can be historically an amusing thing, but in reality, when you actually look into it, it can also be something that's quite frightening. As I said to you, Romain, we did discuss earlier a story about what happened when I accidentally spilt 50 mils of this coolant on the floor. And I asked the cleaner to kindly come in and assist me in cleaning the floor. And I left him to it. He did the standard thing. It's the floor. He gets a nice hot mop with water and he goes and mops the
Yeah,
floor for me.
as you should.
Yes, okay. Yes, he should, yeah. But the first thing that's to notice here is, hang on a second, oil and water don't mix. So oil and water with a nice hot mop is going to reduce the viscosity of the oil, assist it in being able to spread further. And that's precisely what happened. And we didn't realize at the time, and this is where it's funny looking back, had we thought about it. Simple task, mop and clean the floor. Boy, what a mistake. I left him, as I say, and they came to me and he said, Tony, I've got a problem. I said, what's the problem? He said, I can't stand up. And I'm like, what do you mean you can't stand up? You stood in front of me talking to me. He's like, no. I cannot stand up in the room. I'm like, what are you on about? He said, come see. So I went to see him and we opened the door to the facility and the floor was like a mirror. It was unbelievably reflective and shiny. And I was like, so pleased with the floor. I said, you are excellent. What are you on about? We said, watch this. And he took one step into the room. And right in front of me, he ended up on his back. I'm like, what? What's going on? So he said, the floor, it's gone slippery. So I put my foot in, toe in. And yeah, what was a rubberized painted surface, because it was on concrete, I will point out, this became like an ice rink. I'm like, we got visitors coming tomorrow. You got a couple of days. You're going to have to clean this somehow. He said, okay, I'll go and get a power buffer. That should get rid of it. I said, yeah, good call. I'll put some polish down and that should clean it as I would normally do. I said, okay, yeah, no problem. So he went, he came back. I'm still stood at the door. He gets his power buffer. He puts it into the cleaner socket and he pulled the trigger. And then he was gone. He shot off down the data center hall, the Immersion hall, until the end of the power cable. And it was like a cartoon where the Hoover reaches the end of the power cable comes out of the socket, the Hoover stops. And that's exactly what happened. It literally launched him down the room. And he was catapulted towards the wall, which was kind of comical looking back at the time. At the time, it was not. It was a bit of concern. And he had to come back to the doorway on all fours, hands and knees. And I was seriously got to sort this. How are we going to sort it? That comes into lack of knowledge. And so what we did was we literally rang up. We were ringing the oil manufacturers and saying, "What do I do if I've got a spill? What's the best cleaning materials? How do we do it? We've got some soap roll, we've got degreaser." And they're like, "Whatever you do, do not spray degreaser. Yes, it will reduce the viscosity of the oil, it will actually make it float, etc., but you still will not be able to mop it up." Oh, well, we've got the soap roll, which is like a giant form of toilet tissue. Engineers in car garages use it for when they spill oil. That is a logical suggestion to me. And they said, "No, don't do that." And I'm like, "Why?" And they said, "Well, you use tons and tons and tons of this stuff because you've got a big floor." I'm like, "Okay, so how do I do it?" And they said, "Go and get some diatomaceous earth, spread it on the floor, throw it around." So I'm like, "Okay." And then they said, "Sweep it up with a brush." I'm like, "Okay." So we went off, got some diatomaceous earth out of our normal spills kit, threw it on the floor, and it was incredible to watch because this little powder sort of like congealed with the oil on the surface and became into like little balls. And yeah, they were right. You could sweep it, you could brush it. And as we were brushing it, the floor became super tactile. So it was like the opposite side, like you were standing on sellotape. And that's how crazy it was. So we swept the whole floor, we went round with a hoover, and the floor was restored. But it took a lot of phone calls to learn that. And just that one little hint is part of sharing information which people will benefit from. This stuff, this oil is viciously slick. It is amusing when it happens. After when it's happened. It is not so amusing when it happens because you've then got to think on your feet. But there's just one example.
That's an amazing example, and yeah, I can imagine afterward that makes for a good story, but during and on the moment it's quite a stressful situation. I we'll come back onto the points of learning and knowledge in a minute, because I think we can unpack that a bit further. But I'd love to talk about the support tools, all the things that, because we're talking about liquid cooling here, but there are so many other things around it. And air coolers got their own monitoring, and they've got their own equipment that goes to support actually the action of cooling the servers. What does it look like for liquid cooling today?
Well, okay, so I've seen at many different shows, many different modeling software where you can actually model airflow within a data hall. You don't have that in a bath. I've seen many DSIMs or BMS systems. Do we have one that's designed for immersion cooling? No. What we have is a DSIM or a BMS that's designed specifically towards movement of air and that of air handling units for crack units and stuff like that. But we don't have one for oil. These are modules that can be built, and that's the thing that you have to do. So we had to take a standard DSIM and modify it and build a new module, which was the bath. But then when you start looking at the bath itself is like a giant bucket. It contains a liquid. But to maintain that liquid in the bucket, you've got pumps, you've got pressure monitors, you've got flow monitors, you've got temperature monitors, you've got fill levels, you've got low levels. That's just on the bath. You've then got exactly the same for the water loop, which is actually the secondary part. The CDU on a bath runs two different flow systems. Uses one for oil inside the bath and one for liquid, as in water, to take the heat from the oil to an external use. And I'm using that phrase rather than saying chillers or DX units, because you should be reusing the heat it's in liquid. You then take all of those, you've then got to double up on your liquid flow monitors. And before you know it, you then also need to include the power side. In the case of immersion cooling, it is strongly advised and heavily advised that you should be working remotely. So you should not be powering up individual servers physically in front of them. You should be doing it remotely on the PDUs. So you then need to monitor the PDUs. You need to monitor them for the obvious power, current, voltage, etc. Harmonic. You also need to be monitoring temperatures on the PDUs themselves, not necessarily the servers. Their heat is handled within the bath. But all of this sort of thing you need to start monitoring. You can also be monitoring the power and the heat that's contained in the water. As I say, before you know it, you've got an inordinate amount of monitoring points. So you're no longer taking, I don't know, 15, 20 monitoring points in an air-cooled server, just in the rack. You've 200 to 300 monitoring points in a bath. Now, those 200 to 300, yes, are heavily biased on the fact that you may have 25 servers in there. So therefore, you just on the power alone, you're going to have 50 monitoring points. And the reason you say that is the servers that are coming are always dual power supplied. So you've got A and B feeds, so you need to monitor them both. But there are so many different other areas. Heat reuse. What heat is in the water that's going outside of the bath? You need to monitor the flow of that, the pressure of that, the temperature of that. And then that is a mathematical calculation from those to actually get you the power in energy or kilowatts, etc. So there's yet another side of things that all have to be monitored, and they have to be monitored in real time. Excuse me. They have to be monitored in real time because as the data center is the custodian of servers and services in air, we are now the custodians of servers and services in oil. And so the same applies. Problem is, it applies on a bigger scale and a much more critical side of things because the figures are higher. The figures are higher. The power is vastly bigger. The flow rate we are monitoring liters a minute, and the reason we're monitoring liters a minute is because you take 100 kilowatts in some bath, and by reducing the flow to a bath, you can increase the oil temperature in the bath by 10 degrees in 5 minutes. So you actually reach the point of, quite quickly, flammability or volatility of the oil, which is a health and safety nightmare. So you have to monitor this 24/7, 365, as often as you can reasonably do it, which is an insane amount of data. You could sit all day and watch graphs going up and down and up and down and up and down. Or what you could do is start looking at consolidation of that information and getting a tool to read all of these 300 points and actually put it in English. And it may just turn around and say, hey, Tony, you just had light volt drop on the chillers and the pumps outside, which has slowed your pumps down. Well, what has happened is it recovered in 30 seconds, so you don't need to panic. Or it could say, hey, Tony, just to let you know, your water coolers that are outside, cut down because it's popped a fuse somewhere and they're no longer running. You've now got a countdown timer and it was 5 minutes. It's now 4.5 minutes. It's now 4 minutes. As your temperature is rising degree by degree by degree. And before you hit the point of volatility of the oil, you actually also have to monitor the temperatures on the servers using the BIOSes, because it is vitally important. Different servers have different P cases for the chips. The same chip in one server can be completely different T case in another, just because of the position and the location. And this is all the sort of information that needs to be disseminated and taught into your DSIM so it knows what it's recording and where. And that's why, strangely enough, we were looking at getting AI to monitor AI, because the amount of different parameters that had to be computed there and then could put it in English, was quite staggeringly high.
It's it's a very interesting one because we're talking now about tools to control the way the infrastructure is being laid out in order to better cool the servers, and yet you and I have talked about before about also the lack of standard around even the infrastructure itself. Number of oils that are being made available, and the research that's still ongoing to have to find the most efficient ones, the different formats, the different integration path between the tank, the servers, the cables, and so on. Do you see at some point, at least, that we're converging towards a standard when it comes to liquid cooling?
I would like to say yes, but I'd say at this stage we're still investigating. And the reason I'd say that is there are multiple forms of liquid cooling. The obvious one being direct to chip. You've got immersion cooling, of which there are two standards. You've got single phase and you've got dual phase. The three combined is the liquid cooling standard. We know that we've got to cool a chip. That's about as much of the standard as we can get. Do we have anything which is going to say, you cool a chip in this way using this technology and you house it in a bucket? No, we don't. If you look on the markets, you have 10, 12 different immersion baths that are available for sale, for purchase. Some are using convection cooling. Some are using in-rack convection cooling. Some are using direct cooling, as in directional immersion cooling. And then we still have the direct to chip. That is more of a standard. That has a standard because people are not trying to reinvent the wheel. What they are doing is trying to cool a chip. And so direct to chip is actually using manifolds over the chips and directly cooling individual microprocessors and different areas of the microprocessors. In immersion cooling, you've got dual phase and single phase. They both do essentially the same thing, which is cool the entire server, not just the chip. And what it does is it finds and cools that area by volume. In other words, your entire server is cooled, even though you only want one microchip cooling.
Mm-hmm.
That's not a bad thing. It's pretty good. Can you do it convection wise? Yes, you can. Can you do it by using assisted convection, by pressurizing and directioning the fluids? Yes, you can. But again, there's no standard. Then you look at the oils. Should we all be using crude-based hydrocarbons, or should we be using plant-based? Which one should we be doing? There is no definitive standard. The only thing that I can find that is of interest is the sustainability of the oils and their production. Who or which has the higher carbon footprint? I would have thought that a crude-based oil would have a higher footprint, but not necessarily. Plant-based oils have quite a high footprint. So you have to balance that part out. But that's down to somebody in a more higher paid role to make that decision. The UK is going to, or the industry is going to be 100% plant-based. Who knows? Somebody needs to make that decision. It is so rapidly changing. Oil, there's over 100 oils that I can think of. Oil manufacturers from Japan, China, although we're not allowed to use them, Americas, Europeans, everywhere. If you can think of a plant, you can make an oil from it. And that's it. And people are jumping on this at the moment because they know it's the next big change in the industry. Data has always been the modern gold, but keeping that modern gold cool is the new platinum.
Yeah, we've seen a number of actors appearing in data center conferences, which we didn't see even up to 2 years ago. So yeah, effectively, very much a change of scenery. And so your expectation is that those companies are still producing different types, testing different types, and really trying to figure out what is the best products to put out there. I assume.
Yeah, and that is one thing. I mean, like you do get every single chemical that comes into the United Kingdom, be it an oil, be it a chemical of whatever, has to have a safety data sheet. Now, safety data sheets are notoriously long, 6, 7, 8 pages long of chemical details, how the oil is constructed. They give you the chemical formula of the oil. It's an insane thing. But nowhere does it say this oil is perfect and the ideal result for immersion cooling or liquid cooling. What you have to do is you have to read between the lines. You have to look at the vaporization point. You have to look at the volatility, the toxicity. Some of these oils are insanely toxic, be it through ingestion, inhalation, and they can also be very, very damaging just by touching some of them. We have to think about that, let alone we also have to think about materials compatibility, which is a massive subject. I
Mm.
think it's OCP have 128 different criteria for an oil to be classed as compliant. And that is the
Right.
compatibilities from uh, bleaching of colors, expansion of diameters. So in other words, where the plasticizers are actually inflating, the volcanicity of the rubbers or the plastic that are actually in use. What about the way that the oils interact with thermal compound? All this sort of thing has to be fully investigated by anybody considering doing immersion or liquid cooling. It's a minefield. You have a lot of research. I know from my experience in the one that we did, we narrowed it down to 2 oil manufacturers, one from Europe, one from the States. And what we had to do was look at their data sheet, page by page, line by line, to understand that standard before we could actually make a decision on which one we were going to use. And that took us, I'd say, about a month and a half. And that's just one standard.
It brings me to the next part of the podcast we wanted to talk about, because you are, as an individual, extremely knowledgeable on what to do, certainly what not to do as well. I guess there is a few learning points there.
Don't put it on the floor.
But but out of all of this, you're not the only one doing practical tests on all this. Uh, How
No.
is the industry today organizing itself to share that knowledge? Do you see anything coming up? Do you have any places where you can group, or you've seen a group that is specialized in immersion or liquid cooling that can actually share all of that knowledge?
Okay, I'll answer that with I'm going to go back. When I started in this, I said I had to self-teach. There was only one person that I was aware of in the UK who had designed, built, and operated a liquid-cooled data center. That person took his skills and is consolidating outside of the UK, where he's actually working. Here in the UK, there are oil manufacturers who are doing a lot of very, very good investigations into the characteristics and the operability of the fluids. And I think that's great. And for someone who is considering going into immersion cooling and liquid cooling, it's worthwhile a trot down to that particular oil manufacturer. They You will gain an impressive insight into the industry. That's one. That information, a lot of that information They have public information. They have information that they keep themselves, which is understandable. It's business. Is there an industry destination of choice for learning about immersion cooling? No, but there should be, and there soon will be, I will say. So we know about the NDCA, the National Data Center Training Academy, who are going to be running immersion cooling courses and events like Data Centers of the Future. There are online training courses by the likes of the DTD. I'm not familiar with their training course for the immersion cooling, but I am familiar with their air-cooled and basic data center technician courses. Extremely good. If it follows that sort of level, then that course will be an interesting one. There are no forums that I am aware of whereby a data center is able to talk to its peers and learn, because we all keep our secrets secret. There are trademarks, it's our IP, but there are crossover points. We all have to keep things commercially advantageous to ourselves, but the crossover point has to come on safety. And that is one where I personally believe that information should be shared freely, like Volvo did with the seatbelt. The value of keeping that particular patent to themselves was outweighed by the fact it saved lives. And people need to be aware of that you are dealing with a volatile product. It is an oil, which is a fuel. You are heating it, which is two sides of the triangle. Just throw in a bit of oxygen and you've got a flame. And people need to understand that. And they need to understand the impact. Can you get all this information from the bath manufacturers? Not all of it. Can you get it all from the server manufacturers? Oh. Where are you going to get that? And it's only through people who are prepared to talk and explain it. And so the likes of this particular podcast from the iMasons is quite an important one. And I'm hoping that people will review it in its entirety, because I do feel that this is one way that it can be shared, and this information does need to be shared. There is a hole in the industry at the moment, and that is the people who have been there and done what I've done. There's an organization in Spain who have started up doing consultancy for liquid and immersion cooling. There are a couple in the States. There is very, very few across the whole of Europe and Asia, and in different parts of the world. But it is slowly gaining traction. But that is only by the fact that people who are talking about it and consulting on it have to have a background in design, build, and operate. And that, at this moment in time, due to the youthfulness of the industry, is very, very few persons.
I mean, Tony, this is incredibly powerful, and I can't fault you on the fact that our primary concern should be safety, and we want to avoid the horror stories that we have seen in air-cooled environment all the same, right? All over the years, and both having been in operations, we know what they are. So I can't commend you more for definitely pushing for that sharing of information. Now, let's move forward. Let's fast forward about 10 years. Where do you think we'll be? How is the industry different at that point? Have we overcome all of the barriers to entry in the liquid cooling space?
Okay, you say it to fast forward 10 years. How about we fast forward 10 weeks? The reason I say that is because in the duration of when I was rolling out the project, or the program that I built, which was for an AI immerse solution, the technology advanced tenfold. There's the obvious one for lifting a server and being able to operate or to work on that server outside of the bath was the timescales were elongated. But there is a bath manufacturer who've designed and built an electric crane. That electric crane also has a miniature bath built in it. They don't say that you have to fill it with oil. You could fill it with degreaser, so you could cut down the timescales in actually operating and maintaining your servers by having one of those, because you'd be able to lift the server out, transport it straight across to the other bath whilst it's still dripping, drop it into a bath of degreaser, move it across to your bench. By the time you get to your bench, the oils will have thinned out. You'd be able to raise it up, just give it a quick wipe down, put it on a bench and work on it. That is one advance. And that happened whilst I was actually deploying the solution for the customer that we had. 10 years in this industry, we are at the start of a revolution in data center cooling. And it's going to go at a rate of knots. The advancements are going to go so fast. It is pretty spectacular. Look at how much in the last 2 years that the power required for servers has grown exponentially and continues to do so, to the point of some chip manufacturers are making calls for inordinate scale power that we would never have thought. We would normally have historically delivered that entire power footprint, not just to one server. We'd have actually delivered it to an entire 47U of servers. And now we're delivering it to one server. Again, when I started the project or the program that I was working on, and in the period of July through November, which is a period of 5 months, the power footprint went from using 32 amp single phase PDUs to 63 amp 3-phase and 125 amp 3-phase PDUs. That was in a period of 5 months. And that was only by the growth of the power consumption just in the servers alone. Where's it going to stop? We had Moore's law, which limited the chip manufacturers.
That's very much anyone's case at that point. That's for sure.
It is. We had a limiting factor, which was Moore's law, as I said, and that limited the chip manufacturers, and that's why we stagnated. The moment that was broken, boom, the industry has just exploded. The advent of immersion cooling. In the first 2 years that I was working on it and researching, I saw servers that were coming out of server tier 1, which were just staggering scale, and still continued to do so. In January of this year, I saw a range of servers which were insanely powerful, and they were not GPU. But then again, the GPU industry has just come out of nowhere, and it has exploded, and it will continue to do so. We are going to have to try and keep up. And that's one of the problems. The risk factors are going to keep coming back to the data center, because we're the people who have to pick up the pieces and figure it out. Information sharing going forward is going to be critical.
Yeah, that's that's quite a signal as to what's to come. Tony, we're just getting to the end of it. You've always been very open about sharing your knowledge and experience with the rest of the industry. Maybe now would be a good time to share your contact details.
Yeah, feel free. I don't know how you're doing it. There you go. There's an email address.
There you go. Look, I can't thank you enough for sharing your experience today. Very enlightening for myself. I'm pretty sure for the listeners it will be all the same. I've certainly learned a lot, as is not exactly my background. But I do appreciate actually you sharing all of your experience on this. So for our listeners, thank you very much for staying with us all that duration of the episodes. We thought that it was insightful and useful. Tony, I want to thank you again for coming on.
You're welcome. You're welcome.
And if any one of our members actually fancies coming in and taking Tony's seat on the next topic, please feel free to contact me directly, romain.truncheon@imasons.org, or through the Forge app, so you can get in touch directly with me. But until then, Tony, thanks again for coming on, and we'll see you next time.
Thank you.